Welcome to the next lesson of coordinate geometry. In this lesson we will be talking about the gradient-intercept form of a line. Now when we talk about forms and the different ways they can be presented, we're not talking about anything daunting or something new. We're just simply looking at the different ways in which we can write an equation, in our case linear equations or straight line equations, and the kinds of information they can show us. So with a gradient-intercept form, it is nothing new. It is something that you would be very familiar with looking at already. But what we're going to do is delve a little deeper into the actual meaning of the numbers in certain places. So let's have a look at the gradient-intercept form of a linear equation. A straight line in a gradient-intercept form makes it easy to identify the gradient and the y-intercept. So here you have the gradient-intercept form encircled in black, and it's y equals mx plus b, where m is the gradient and b is the y-intercept. So straight away we are able to pull out two very important bits of information about a linear equation just by looking at the way it is written. As long as it is written with the y over here on the left by itself, no other coefficient of the y, it is just a y, it is a positive y, and it's by itself. And then we have an mx plus a b. Now, it doesn't always have to be plus b, it can be a minus a number there, and that just represents a negative y-intercept. What we're going to do is we're going to have a look at an equation and how these different aspects affect the graph. So here we have our equation. It is f of x equals x. Now, f of x can be written as just y. So we can say we have y equals x. Now, looking at our gradient-intercept form, we had y equals mx plus b. And what we have at the moment is just an f of x equals x. So we have no b, there is plus 0. So our graph is crossing the line here at the origin, or the y-intercept is 0. And our coefficient of x, just because there's nothing there doesn't mean it's a 0. If it was 0 times x, there would be no x's and the x simply wouldn't be there. So it is a gradient of 1, which represents, if we start here at the origin, rise 1 and run 1, we are back on our line. Now, if we have a look at what happens when we change this value, so I'm going to increase m. M is now a 2 rather than a 1, and you will have noticed that our gradient, the slope of the line, has changed. Now our rise has become 2 and 1 across. And that is our rise over run, that is our 2. We can keep changing our gradient to be 3, our line gets steeper and steeper every time we do that. Now, just because of the limited size of our graph here, we're seeing the changes, but we can't actually look at what's going on. 10x, so for every 10 that we rise, we go across 1, and that gets us back on our line, so that is quite a steep graph. If we start changing that down, we're dropping the value of our gradient, y equals x, and once we hit a negative x, our graph is starting to go down now. So for every 1 our graph drops, we go across 1, that is our gradient of negative 1, and that's how we get back on the line. And if we change that gradient and keep dropping it, it simply becomes more and more negative, becomes more and more steep, but remaining negative. So that is our gradient. If I change this to a 2x, now we're going to change the c. Now, just for personal note, while this application says c, it's actually talking about the b in our formula. It is just one of those things where some people like writing c and some people like writing b. And what it's going to do is it's going to add a coefficient out after our x value. And if we increase our c or b value by 1, our y-intercept has changed to 1. If we increase it again, our b value or our y-intercept is now 2. Increase it a couple more times, we have plus 4 in our equation, and our graph is crossing the y-intercept, and our graph is crossing the y-axis at 4. Similarly, if we drop it and make it negative, we have a minus 3, and our graph is crossing the y-axis at y equals negative 3. So there you have it. That's the gradient and the y-intercept, where they are in an equation and how they affect the graph. We'll move into a few examples just to have a look at what kind of questions you may be expected to answer. Okay, so our first one is find the gradient and y-intercept of y equals 3x minus 4 all over 5. So first off, if we're trying to use our formula of y equals mx plus b, you'll notice that there's no number being divided by all of them. So what we need to do is separate our denominator and make it y equals 3 over 5x minus 4 over 5. If everything's being divided by 5, we can separate that out and have each term being divided by 5. Now it becomes a little easier to identify our gradient and our y-intercept. Our gradient of m is equal to the coefficient of x, and our coefficient is simply 3/5. Our y-intercept is equal to, now in our formula we have a plus b, but in our case it's minus 4/5, so that means our y-intercept is negative 4/5. And that's all there is to it. We've identified the gradient and the y-intercept from just the form of the equation. Okay, in our next example here we have 4y minus 3x all equaling 9. Now that's not in the form that we need. We need y by itself and we need the y with no coefficient. So what we need to do first is move our 3x across. It's minusing 3x, so we need to add it. So we have 4y equals 3x plus our 9. Then to suit our equation we need y by itself, so we need to move the 4 across, and it's 4 times y at the moment, so a divide is the only way we're going to get rid of that. Y equals 3x plus 9 all divided by 4. Now it kind of looks very similar to the question we just answered. We cannot identify the gradient or the y-intercept as it is. We need to split the denominator to be under each term separately. So now we're going to pull out from our equation the gradient, which is the coefficient of x being 3/4, and we're going to pull out the y-intercept, which is the number on its own being 9/4. Or for those of you who prefer mixed numbers, it is 2 1/4. Okay, let's have a look at another example. Now in this question we are asked to write the following information in gradient-intercept form. So we have a line with a gradient of negative 2/7 and a y-intercept of b. So starting out with the general form of our gradient-intercept is y equals mx plus b, where m being the gradient and b being the y-intercept. So we have y equals, now here is our m value, it is negative 2/7 multiplied by our x plus our b value being 3/5. So it's plus 3/5 on the end. Now we can clean that up and try and make it so they have the same denominator and all over the one, but ultimately this is a more useful representation of our gradient-intercept form. The terms are separate, both the x coefficient and the intercept are separate. This is a much more useful way of writing our answer. So we're going to leave it as negative 2/7 of x plus 3/5. And that's all there is to it. Okay, moving on to our last example, and it's just a different way of asking the question. We are asked to find the equation of the following line, and line of course being the interval. So here we have our points negative 5,3 and 5,8. What we're going to do is add on our little right angled triangle, because first off the two bits of information we need are the gradient, we need that, and we also need the y-intercept. What is that? The gradient is, as many of you will remember, rise divided by the run. Putting it in a more coordinate friendly form, it is y2 take y1 divided by x2 minus x1. Now our y2 value, I'm going to label x2 and y2 as the point on the right, and x1 and y1 as the point on the left. So y2 is 8 minus 3, all divided by x2, which is 5, minus negative 5. 8 minus 3 is 5. and 5 minus -5 is 10. Simplifying that fraction down, our gradient is simply just 1/2. Now we need where the graph crosses the y-axis. We can see that it is here, and if our graph is accurate, we can simply read that point off. We've got 1, 2, 3, 4, 5, and I'm going to go with 5.5. So our y-intercept, being a coordinate, x is 0, and our y value is 5.5. So filling that out in an equation, we'll scroll down a little bit while leaving the key bits of information. So the formula states that we can write an equation of a linear line as y equal mx plus b, where m being the gradient, so it is 1/2 of x plus our y-intercept, which is 5.5, or leaving it in terms of our fraction we've got here, it is 11/2. We can tidy that up and say we've got x plus 11 all halved, just to sort of minimize the amount of fractions we got, but ultimately this first answer we had here is going to be more useful to us in the future. So there you have it. That is the gradient-intercept form of a line. Nothing new, it's just now that we have some extra bits of information, so we can use that in helping us write equations of line, or having an equation and finding key bits of information from it. Thanks for watching the video, and good luck.